So Buro Happold is a global integrated consultancy for engineering designers and then advisors working within the built environment. And we've worked on some of the major infrastructure projects across the world. We work from the building level all the way to the city or policy review and impact assessment. And then we have a lot of the built environment experts. So when we are working on project, we bring all of them together to solve multidisciplinary challenges and then also deliver infrastructure projects. And this is key to the way we also deliver data and digital solutions, because we bring on board our internal knowledge base to integrate into the way we deliver digital twin solutions. So I'm going to then narrate the integration and data models around a case study application. So this project, the client requirement was to use digital to integrate an exciting urban environment and then achieve a lifestyle community. And to be able to do that, they set as a key set of requirements. So they wanted the digital twin to represent the physical development of their business, so that they can then increase operational efficiency, allow for resource optimization, asset management, deliver cost savings, and improve productivity. So one project, multiple requirements. So some of the key objectives were data and systems integration and interoperability to be able to deliver the use cases that we were set, and then also allow them to be able to connect to the various stakeholders working on the project, because it was a multi-billion-dollar investment, and that way is bringing in various entities and then also experts to work on the regeneration of a city center. They also wanted to be able to integrate project scheduling so that they can then simulate and understand the context of the delivery and then replan. They wanted to look at design exploration of the master plan so that they can then test what if scenarios. So series of examples. But to be able to achieve that, we had to then understand the critical challenges that were facing the organization. Some of these were like the volume of data, and then the differences. Also, different stakeholder groups have their own ways of capturing and managing data. So you need to be able to understand them so that you can then synthesize. And then also standardization, data standards and protocols was also critical player. And then the quality of data, because of the cultures of organizations involved, it then brings these challenges on quality. And then, for instance, metadata, you're looking at lineage and then legacy systems is really some of these big challenges facing the organization. But to be able to achieve that, Ahmed has highlighted some of these concepts, we need to then understand the complexity of the digital twin solution that we need to deliver. And then for us, we have these models that we've brought together. But the critical components to achieve integration or interoperability is about the partnerships and then stakeholder requirement that sets the definition of the case studies for us to implement. And then that would then define the data, whether it's structured or unstructured. And then how do we set different standards or protocols or bring in different existing best practices to be able to achieve effective integration and interoperability. Once you then build these four key areas together, you'll be able to then share the data within different interfaces or apply advanced analytics, automation, and then the technology infrastructure. By using that approach, we then go down into the integration, how we then understand the different use cases requirements, how do we then break these use cases into ontologies and define the vocabularies using existing set of vocabularies within the domains that we are operating in. And that would then define the governance and implementation language and tools to be able to architect the data models that we need to be able to understand or derive the use case outcome, so that we can play that into the digital twin output. And then once we've understood that, then we've been using the ODA methodology of data ecosystem mapping, so that we scan the organization, understand the data flows between different systems and stakeholders operating within the project space, so that we know which of the data sets they are interested in, or how we can utilize them to solve the outcomes that are required. And then how do we also accelerate the interoperability resources about integrating ontologies with knowledge graph and then AI so that we can then automatically classify the complexity and volume of data that is coming in into the organizational structures that we've defined to be able to work on the use cases. And this is the approach that we go through to be able to automate, because the project is being delivered at a faster pace, and we need to be able to deliver the digital twin solution within the same time frame. And then this is an example of how we've built the auto classification, selecting different standards, and then using it to match the client's data to derive the outcomes that is required. They're going through those steps, you then arrive at this outcome where you build an interface to be able to communicate the results of the digital twin. And these are some of the functional components of the digital twin, where the client wanted to be able to simulate or go through the environment, specific tools to be able to understand the complexity and the interrelationship between the different data sets, specific analytics requirements, and then also ability to navigate through. And then it's a platform for multifunctional decision making. So we are looking at master planning and development, construction, real estate, and city and asset operations. So we need to look at the life cycle. So everything that we set at the beginning has to be able to go through the life cycle of the infrastructure delivery across the site. And this is so play the example snapshots of the platform, and then I'll play this video to highlight the outcome. So using the various component data integration, data security is really critical. So user authentication to be able to access the right data that is allowed by the different stakeholders. And then you also have different sets of information coming from different departments to be able to interact with the site. And they wanted us also to mimic the architecture and design considerations, both existing and then the new, and then ability to interact with the existing infrastructure assets, so that you can then understand different contextual information across the sites. And then you can then look at the specific analytics. So integrating different libraries to be able to give the user the outcomes that is required within a gaming environment to show the best-effness. Also, because it's a master plan and there were impact on the existing infrastructure, so constraints analysis, whole series of outcomes to be able to protect critical infrastructure assets or the environment. Also the topography of the site for different construction simulations. Look at this. So within one platform, we have multiple analytics and use cases to be able to realize the objectives of the client. So ability to undertake clash detection about what they are going to build against the existing assets, and then the decision-making processes. Also logistics planning about road closure simulation, so that if you are doing construction or carrying goods across the site, you can then see the impact. Also ability to do immersive navigation through the site and then understand how the future state of the environment is going to be. You also have a project simulation, so notifications. Also, anytime you make any changes or design consideration, you can then notify different stakeholders, and then it gives them access to the information that has been done. Also, live scheduling. This is integrating Primavera project P6 data into the construction assets, so that you can then test what is going to be delivered at different periods of the delivery process. And that way you have that in context. You can also make changes between the stakeholders and then also the experts, and then look at the GFA calculations, massing, and then integration with even planning policy to look at the different building typologies. You also have nighttime simulation. You can look at the energy demands calculations in real time to understand the impact on some substations or any other infrastructure delivery. So this gives you context about what comes out of the process that we have to go through. And then the lessons that have been learned from that process is that stakeholder involvement is critical because it's their digital twin, not the expert perspective. We also have to understand different cultures in the way they manage data. We need to start more and then increment. And it's not about the shiny software solution. It's encapsulation of a whole lot of components and models and different use cases. And then the outcomes and purpose is really crucial because if you don't know that, you wouldn't be able to achieve what you set out. And it should be modular so that we can then scale, and data quality is really
20 seconds left.
Thank you. I'm done.
And Anthony, with regard to your use of ontologies, are you using them exclusively for tagging, or how else are you using them?
No, it includes the integration, tagging to achieve integration, also data security, and then authentication, so assigning the relevant users to the specific data sets that they've been allowed to view or utilize. It's also for the automation and then analytics. So it helps you to build the digital twin at a faster pace. Everything that you want to be able to achieve, the ontologies will allow you to do that.